So today we are taking sums of series, and these are geometric series, and it is a little bit different when we have an infinite geometric series, but we can find the sums of them. Okay, so an infinite geometric series is a geometric series where the sum levels off and approaches a limit where -1, underline this, is less than r is less than +1. This is the most important part for us to check on a geometric series. Okay? That r is bigger than -1 but less than +1. Very important. Okay? Okay, so, and there's a typo here. A geometric series looks like something like this: 1 plus 2 plus 4 plus 8 plus 6. It's being multiplied by 2 each time, right? But it stops eventually. An infinite geometric series is something that it goes on and on forever and ever and ever. So it has the ... at the end. Okay? Alright, so we have a formula. The sum of an infinite geometric series, sum, equals a sub 1, the first term, over 1 minus r. But you need to check that r is between -1 and 1. Okay? So if we figure out what r is, and it is not between -1 and 1, there is no sum, and we don't have to do any work. Okay? So example 1. Find the sum of each infinite geometric series if it exists. That's very important. If it exists, it might not. So, hint, first find the value of r to determine if a sum exists, because you don't want to do all of the work to realize that there's no answer. Okay, so looking at the example, 8 plus 4 plus 2 plus ... What is r? This is geometric, so it's multiplying. Times 1/2. Is 1/2 in between -1 and 1? Yes, it is. So there is a sum. Okay. The sum equals a sub 1. What's a sub 1? 8. So we're going to plug in 8 over 1 minus r, which is 1/2. Okay, so this gives me 8 over, what's 1 minus 1/2? Half. Good. Okay, now this is a number divided by a fraction. So if I am dividing by a fraction, is the same as multiplying by the what? Reciprocal. So is everybody okay that this is the same as 8 times 2? Okay. What's 8 times 2? 16. That's my sum. So even though this is going to infinity, if we were able to go all the way to infinity, it would all eventually add up to 16. So we can see that it's getting closer and closer and closer to the number 16. Okay? Not too bad? Okay, so example 2. What is the sum of the infinite geometric series of 1 minus 3 plus 9 minus 27 plus ... Let's first figure out what is r. If I'm going from a positive to a negative to a positive to a negative, my r has to be what? Negative. How do I get from 1 to 3? Times -3. And then -3 times -3 is positive. 9 times -3 is -27. So r is -3. Is -3 between -1 and +1? No, it does not lie between those two numbers. So we can stop, and we know that it does not exist. So we're done. Not too bad, right? Always check that r is between -1 and 1. Otherwise, you're going to do a whole bunch of work for no reason. Okay? Example 3. Find the sum if it exists. Now, these are really nice because remember how when we were doing these before, if I give you the summation notation, everything is already there for us, right? Okay, so A is the sum from 1 to infinity of negative 1/2 to the n minus 1. So what is R? R is this thing right here, negative 1/2. Is that between negative 1 and 1? Yes, it is. So there is a sum. So let's plug it in. We need to figure out what a sub 1 is first, though. What's a sub 1? Remember, this is my formula. A sub n equals a sub 1 times r to the n minus 1. Here's my summation notation. There is no a sub 1 there. So what is a sub 1? A sub 1 is 1. Since there's nothing there, it's like multiplying by 1. So a sub 1 is 1. So this is 1 over 1 minus negative 1/2. There's that better. Okay, minus a negative becomes what? Positive. So this is the same as 1 over, what's 1 plus 1/2? 1.5, which is 3 over 2, right? Yes? Okay. Dividing by a fraction is the same as multiplying by the reciprocal, so this is 1 times what? 2/3. So what's my answer? 2/3. B. The sum from 1 to infinity of 3 times 5/4 n to the n minus 1. What is R? 5/4. Is R between, or is 5/4 between 1 and negative 1? Five fourths is the same as 1 and 1/4. Is that between 1 and negative 1? No, it's too big, right? So we stop. No sum. Okay? C. What's R? Well, if R was 3 over 4, then going from here to here, the numerator would be 9. So the numerator has to be 1, and the denominator is 4. Is 1/4 between 1 and negative 1? Yes, it is. So we're good to keep going. So the sum equals a sub 1, which is 3 over 1 minus 1/4. So this is 3 over what? 1 minus 1/4.
Oh, minus.
3/4. Dividing by a fraction is the same as multiplying by the reciprocal. So this is 3 times 4/3. Oh my gosh, this is going to work out so nicely. What happens? The 3's cancel. So what am I left with? 4.
Why is it 3? Oh, it's 3/4.
Do you guys remember repeating decimals?
Yeah. You write the number with the line over it.
You can write the number with the line over it. We can actually take a repeating decimal and write it as a fraction using sums. Because a repeating decimal is really just a infinite geometric series. Let's think about it. What number is being repeated right here? 64, right? This part right here, and then it just keeps going over and over and over. So if I took 64, the number 64, and multiplied it by 0.01, that would give me 0.64, this part right here, correct? Okay. What if I took 64 and then multiply it by 0.01 to the second power. That would give me 0.0064, this part. So if I add this part and this part together, I get this thing. Do you guys see what I'm saying? This right here is 0.64. This right here is 0.0064. So does adding this and this together give me this part right here? So what would the next one be? 64 times 0.01 to the third, because that would give me 0.000064. Dot, 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 so on and so on. Does that make sense? Okay. So what would R be then? What am I multiplying by each time? 0.01. So R is 0.01. Is that between 1 and -1? It is. So let's use a sum. Sum equals the first term. What's the first term? 64, yeah, 0.64 or 64 times 0.1. This thing right here. Over 1 minus R. What's R? 0.01. Okay, 64 times 0.01. That gives me 0.64 over 1 minus 0.01 is 0.99. Now let's write this as a fraction with whole numbers. This is the same as 64 over 99. Right? I can just move the decimal over 2 spaces. Can I reduce that at all? You can't, actually. So this is your answer. That's all they want us to do. Not too bad, right? This is the same, pretty much the same process every single time. When we are looking at something like part B, there's only one number being repeated. What is it? 3. So the sum is a little bit different, or R is a little bit different, but it's kind of the same idea. This is the same as 3 times, not 0.01, because there's only one term, so point what? Just 0.1. Plus 3 times 0.1 squared, plus 3 times 0.1 to the third, plus dot, dot, dot. So what's R in this case? 0.1, right? Is that between 1 and -1? So let's do the sum. Sum is equal to 3 times 0.1, that's a sub 1, over 1 minus 0.1. So that equals, what's 3 times 0.1? 0.3, or 0.3, over 1 minus 0.1, 0.9. Can you write this as a fraction with whole numbers? 3 over 9, and that reduces to 1/3. So 0.333333 is the same as 1/3. And isn't that true? Don't we already know that? Yeah. Okay?